So this is the part that we are going to dedicate just on rational numbers. So if you are going for a test on this topic, you need to recap rational numbers. So as I mentioned in the basic concept, rational numbers are any numbers that can be written as a ratio of two integers. And I also mentioned that ratios can also mean fraction. So we will be using fraction to relate to rational numbers. So currently, I would like you to think about rational number looking like this. So rational numbers look like whole number divided by whole number. So like I mentioned here, the numerator and denominator are integers. So I'm going to give you example. I'm going to give you an example of rational numbers. And what's the opposite of rational numbers? Okay, like prime numbers, the opposite of prime numbers is composite. So the opposite of rational number is called irrational numbers. So you do need to know how to classify rational versus irrational. So at the end of this, right, there's a trick to remember irrational numbers. So let's talk about rational numbers first. Understand what is rational numbers. Then we think about irrational. So rational numbers must be whole number over whole number. So what are considered rational? So every whole number, any whole number will be considered rational. So I will give you an example. Why is that so? Okay, so you think of any whole number like 10, it is actually 10 over 1. So there is an invisible denominator. And if you look, this is a whole number. And this is also a whole number. Okay, so maybe I give you a 3. So that will be 3 over 1. Also whole number over whole number. So there's an invisible denominator that's applicable for all the whole number. So if I give you a -6, it can also be -6 over 1. So as long as I can change it to a format of whole number over whole number, that will be a rational number. So my conclusion here is all the whole numbers are rational numbers. Okay, so then the second one, all the fractions are rational numbers. All the fractions are rational numbers. You can think of fraction like half. You can think of fraction like 5 over 4. You can think of fraction like -7 over 8. Okay, you can also think about mixed number. So what about mixed number? In primary school, you learn how to change mixed number to improper. So that is also a rational number because it's whole number over whole number. So even mixed number can be changed to improper, which is still a whole number. That's why all the fractions are rational numbers. Okay, so the more confusing category will be most decimal. You realize the keyword most decimal, that means not all the decimal. So the decimal must be able to convert to whole number over whole number. A very simple one will be 0.5. 0.5 is like 5 over 10, which is like a half. So whole number over whole number. Okay, then maybe like 1.2. It is 1 and 2 over 10. That will be 12 over 10. So you keep reducing it. And eventually you are still getting a whole number over whole number. So most of the decimal will be rational number. So which kind of decimal are not? So there is a special kind. Decimal with no pattern are irrational number. So decimal with no patterns will be considered irrational. Okay. So later on we'll come to this part where it is irrational. Okay, then what is known as a recurring decimal? Recurring decimal are decimal with patterns. So what are decimal with patterns? Okay, let me show you an example. So like 0.121212. There is a pattern, but the pattern doesn't stop. So all this one can be converted to fraction. There will be some asterisk example that shows how do we convert decimal with patterns to fraction. So at the moment, you just need to know that as long as you see decimal with pattern, it can be converted to fraction. That's why it is actually considered rational numbers. So I'll give more examples. So all these are with pattern. The pattern is for the 4 to repeat. So it can be changed to fraction. Okay, so as long as there are numbers decimal that can be changed to fraction, we will classify them as rational. Okay, so one last example, something like 157. So this one can also be converted to fraction. In the last few examples of this teaching worksheet, we actually have this part that teach you how to convert. Okay, so some of you, right, may be tested for this part if your teacher go through. So examples of irrational numbers. Okay, so the feature will be decimal with no pattern. Example, square roots. If you go and punch out your calculator, you will realize that you will see one chain of decimal and you don't see any specific pattern. Okay, you try punching out. You don't see any pattern in the chain of decimal that's reflected on your calculator. But that doesn't mean it's not all the square root. So if let's say you got square root 4, square root 4 is 2/1. So that is rational. So you must come to the part where decimal with no pattern. So another decimal that's no pattern will be pi. 3.14159265359. Your calculator only managed to show this number of decimal for pi, but there's actually a lot of decimal. So there are some like world record kids who memorize like 100 decimal place of pi or that. Yeah, I don't know what's the world record. Okay, so anyway, you realize that there's no pattern. So pi is irrational. But then, right, if you, in primary school, sometimes we use 22/7 as pi. But this is rational because it's a fraction. But pi is irrational because there are no patterns in the decimal. So in a way, right, if you want to remember what is irrational number, irrational numbers are just decimal with no pattern. So if you want to do a quick summary, what are irrational? Decimal with no pattern. Any other things, right, will be under rational. So that will be the special section on rational numbers. Later, we'll see some examples on this. But that is the review concept if you need to on rational numbers.